All right, we're back. We are on page 7 of notes 21 of Calc AB, and this is just one of those problems that has like everything. And so let's see if we can do it. So we are told that R is the first quadrant region bounded by the graphs of y equals the square root of x minus 2 and y equals 4 minus x over 2, as shown in the figure above. Find the area of R in two ways. So my first concern is that the intersection point here I think is not super nice. And I'm actually I'm gonna solve it on a calculator to like preserve a little bit of time here. So if you will give me 1 sec, well, no, come with me, step into my calculator lab here. I'm going to solve y equals the square root of x minus 2. So I'm actually solving a system because I want to know the x and the y values instead of just the x. 4 minus x over 2, comma x. Okay, can we expand that one? Expand is menu 3, I think. Okay, so this is the ordered pair. That's weird. 10 minus 2 root 7, comma, root 7 minus 1. So I had a feeling that it was like not nice because, you know, radicals and lines don't often intersect in really nice places. So we're going to use those. I'm actually going to store that. I'm going to store that as xc on the calculator, and then yc I'm going to store as this. All right. I'm going to write that on my paper as well. I'm going to do like a let. And then we can just use xc and yc as we go through the problem in the event that we need to. Okay, so let's say let xc equal. So I use xc and yc for, it's like a holdover from when I used a TI-89 way back when, where it would store values as like x coordinate, y coordinate, so xc, yc. And it's pretty convenient because it prevents you from storing something as x or y, which is generally sort of a bad idea because the calculator doesn't like reserve those variables, but it should have. So like if you store something as x, it gets a little weird when you start graphing and you see like a bold x and you're like, is this gonna really work? And it usually does, but you know, you're never sure. All right, so to find this area with respect to x, I'm gonna split it here at xc and do this radical thing from 2 to xc, and then the line from xc to 8, which is actually just triangle, but still. So let's do the integral from 2 to xc of the square root of x minus 2 plus the integral from xc to 8 of 4 minus x over 2 dx. That should get the area one way. I think the other way would be in terms of y. And actually, we can do it with only one integral in terms of y, so like it might be a better choice anyway. So let's see. This is y squared plus 2. X equals y squared plus 2. And then this is x equals, subtract 4 times negative 2. So negative 2 quantity y minus 4. All right, right take away left. So the right curve is the line, and then the left curve is the quadratic type deal. So this should be, I'm just going to say it equals this. We're going to go from 0 on the y-axis up to the y-coordinate, yc, and then right take away left, so negative 2 quantity y minus 4 minus the quantity y squared plus 2 dy. All right, we got to check it on the calculator because I'm not doing that by hand. So let's see, switch in. Okay, so integral, we'll use templates. The integral from 2 to xc of square root of x minus 2. I should probably store that, by the way. Like I'm probably going to pay the price later on for not doing that, but I haven't done it yet. It's 8 4 minus x over 2 dx. So let's get 3 decimals on that. 5.680. 5.680, and let's see if our dy integral gives the same result, which I mean, it definitely should. 0 to yc of -2 quantity y minus 4, and then minus the quantity y squared plus 2 dy. So that's where it's risky because I didn't store the function and I'm trying to distribute a negative. You know, you got to watch out for that. 5.680. Yeah, both times. Nice. Let's go back and see what the next question is. Okay, so we want to find the volume of the solid form by rotating r about the y-axis. Okay, so about the y-axis. Come this way. So this is a big R, little r situation. Confused somewhat by the fact that the region is also named R, and also that's not going to become, it's unwilling to become a straight line for me. All right, so big radius, I'm going to call it like radius, is going to be right take away left. So right is our function here. -2 times the quantity y minus 4, and then minus 0. -2, the quantity y minus 4, minus 0, and then our little radius. So when it's ambiguous, I'll just write it out. Is just going to be right, which is our quadratic thing, minus 0. So y squared plus 2 minus 0. I'm going to drag these with me. Okay, so we're going to do pi, the integral from 0 to yc of big R squared, so -2 y minus 4 squared minus little r, which is y squared plus 2 squared dy. All right, and we can, I'm going to use a calculator to get that in like a little bit, but for now, I'm going to leave that. Find the volume of the solid form by rotating r about x equals 9. Okay, so what I should have done, and maybe there's still some time, is I should have like cut this picture out and just kind of like dragged it with me. Let me see if I can do that now. I'm gonna copy and then like, oh gosh, no, paste image, and like, can I shrink that a little bit? Kind of, just like for convenience sake. I don't know if I can erase. I'd love to erase. Can't erase that though. Man, if only I could go back in time and not have like drawn all over it, but I drew all over it. So we'll deal. There we go. So we're going to get a different big radius, or different big radius this time is going to be here. And we're going to get a different little radius, which is there. Okay, so our big radius is going to be right take away left. So it's x equals 9 minus the quadratic thing, which is y squared plus 2. And then our little radius is going to be right take away left. So it's that 9 minus the linear thing. So that's going to be 9 minus the quantity -2 y minus 4. Okay, and we're still going from 0 to the y coordinate. Like that usually doesn't change when you're, changing up the line you're going around. 0 to the y coordinate. Big radius is going to be 9 minus. So notice I don't bother to simplify this. It's just like another mistake I could make. Minus the little radius. This I am going to make 9 plus 2 times the quantity of y minus 4 and squared and dy. Yeah, that's going to do it. All right, eventually I'm going to use a calculator on these, but like, doesn't really, doesn't really help much. Region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is a square. Write an expression involving one or more integrals that gives the volume of the solid. Use calculator. Okay. E, R is a region perpendicular to the y-axis. Okay, and then horizontal line y equals k. Oh my gosh. Okay, you know what I'm gonna do? I'm gonna stop this here. I'll come back in the next one and finish this problem because I feel like this video is probably super long. So in the next video, I'm gonna start off by finding approximations of these things and then carry on. So I will see you there.